Hello there, you're welcome to my channel. In this video, we're going to be finding the value of a given this exponential equation. So let's start off by using one of the laws of indices. If you notice here, they have a common base of 3. All we have to do, if you have a raised to the power x times a raised to the power x times a raised to the power x, for you to work out this using the law of indices, you can take the common base and add the exponent. So you have x plus x plus x. That's what I'm going to be doing here. So this is going to be 3 raised to the power a plus a plus a. And this is equal to 72. So moving on, this is going to be 3 raised to the power a plus a is 2a. 2a plus a is 3a. And this is equal to 72. What I have to do next is to group this 3 raised to the power 3, all right, and 3 raised to the power 3 is 27. Then you have raised to the power a is equal to 72. It's now time to take the logarithm of both sides because I want to drop a. Okay, so it's going to be log 27 raised to the power a is equal to log 72. Now, from one of the laws of logarithm, this a comes down to the front of the logarithm. So we are going to have a log 27 is equal to log 72. Now let's divide both sides by log 27 since we need to get the value of a. Divide both sides by log 27 here and then here. So this cancels this and a is equal to log 72 over log 27. Now I'm going to express 72 and 27 as a product of prime factors so that I would simplify this further. Now for 72, when you break it down, you're going to have 2 times 36. If you break 36, you have 2 times 18. You can break 18, you have 2 times 9. And when you break 9, you have 3 times 3. So what do you have? 2 times 2 times 2 times 3. See, 2 times 2 times 2 times 3 times 3. Okay, so I will write it, I will express it in index form. So that will be log 2 raised to the power of what? 3, as we have here, times 3 raised to the power of 2. All divided by log, what about 27? 3 times 3 times 3 is 27. So this is going to be 3 raised to the power of 3. Okay, now taking it a step further, a will be equal to, I'm going to split this because if you have log a times b, this can be expressed as log a plus log b. That's what I'm going to be doing right here. So this is going to be log 2 raised to the power of 3 plus log 3 raised to the power of 2, all divided by what? Log 3 raised to the power of 3. Using one of the laws of logarithm, again, as I used before, 3 comes to the front of the logarithm, same as this 2 and same as this 3. Okay, let's do that right away. There's going to be 3 log 2 plus 2 log 3, okay, all divided by 3 log 3. Now what I can do next is to split this like this. There's going to be 3 log 2 over 3 log 3 plus 2 log 3 over 3 log 3. I haven't changed anything because if you add these two fractions together, you're going to have this as well. So nothing has changed. I just want to simplify it. That's why I decided to split the divisor. So 3 cancels 3, log 3 cancels log 3. Okay, what do we have now? A is equal to log 2 over log 3 plus 2 over 3. I can do one more thing, and that would be change of base using the change of base rule in logarithm. Here's how it's going to be applied here. If you have log a base b and you want to change the base from base b to c is going to be expressed as log a base c over log b base c. Now, although it's not written, but the base here is 10 and the base here is 10. So what I want to do is to take it from this form to this form. So I'm actually going to remove the base 10 and then take it back to this form as I've highlighted, log a base b. So we're taking out this base 10 and it's going to be expressed like this. Watch this now. It's going to be log 2 base 3. You know, if you want to change the base, you can write it like the log 2 base 10 over log 3 base 10, which is what we have here. All right. Now, I just took it back to this now using change of base rule. Okay. So let's proceed. And what we have here is now plus 2 over 3. So this right here is the solution to the exponential equation. A is equal to log 2 base 3 plus 2 over 3. Now we need to test whether this answer is right or wrong. We're going to plug it back into the equation and let's see whether it will give us 72 on the right hand side. So I'm going to rewrite the equation again, which is 3 raised to power a times 3 raised to power a times 3 raised to power a is equal to 72. Now for ease of testing, I would simplify this one more time, which I did before. It's going to be 3 raised to power a plus a plus a. Remember, we did this before. Okay. And which is what? 3 raised to power 3a is equal to 72. Now, I am going to now express this as 3 raised to power a times 3 is equal to 72. Because from one of the laws of indices, if you have a raised to power x, y, this can be expressed as a raised to power xy. Okay, so that's what I just did now. I just put a bracket, but a exponent of a and 3 are actually going to multiply themselves to give you what 3a. So nothing has really changed. Why am I doing this? Because I just want to make it easy for us to test our answer. So we already know what a is from what we saw before. A is what? Log 2 base 3 plus 2 over 3. So that would be 3. What's a? That's log 2 base 3 plus 2 over 3. Now remember, we have everything all raised to the power of 3. So we're testing if this will give us 72. Okay, let's do that. Now watch this. From one of the laws of indices, which I've already applied before, if you have p raised to the power a times p raised to the power b, now because they have a common base, this will be expressed as what? P raised to the power a plus b. So as you can see, what I have in the bracket is of this form, but I would want to take it to this other form. Okay, here now watch this. So this is going to be 3 raised to the power log 2 base 3 times 3 raised to the power 2 over 3. Remember, all raised to the power what? 3. Beautiful. Now moving on. Look at this common base of 3 here. And the base of this logarithm is 3. So for every a raised to the power of log, let's say x base a, because this a here and this common base a here are the same, they are inverse functions, so they'll just cancel out and you have x as the result of that. So that's what I'm going to do here now. Log base 3 and this common base of 3 here, they are the same, the base they are the same, so they will cancel out, and that leaves you with just 2 times 3 raised to the power 2 over 3, all raised to the power what? 3. From power of a product rule, I'm going to distribute this power of 3 to 2 and to 3 raised to the power 2 over 3, because it can be applied to the factors in the bracket. So this is going to be 2 raised to the power 3 times 3 raised to the power 2 over 3 with a power of 3. So 3 cancels 3. What do you have? 2 raised to the power 3 is 8, and 8 times 3 raised to the power 2. See, 3 raised to the power 2 from here is what? 9. What is 8 times 9? Is it not 72? So we have proven that the value of a, because we have 72 here, we have now proven that the value of a is what? Log 2 base 3 plus 2 over 3. If this video was helpful to you, kindly like and share this video and subscribe to this channel for more content like this, and I'll see you in the next one.